We're starting in the third section of chapter 10. Today we're getting into surface area of prisms. Tomorrow we'll add in cylinders. Why would prisms and cylinders, here's a prism, here's a cylinder, why would they be in the same section? What do they have in common? They have something really important in common. Do you know what it is? Everybody think. And the thing they have in common is they both have good job, two bases, right? Look at this pyramid. How many bases does it have? One, with an opposite vertex. Good. So the reason these are in the same area is we end up with formulas that are totally similar because they have two bases. Okay? The four prisms that you cut out of paper from the templates last night are nets because you have not folded them, right? So when we talk about a net in geometry, we're talking about one of these figures that is a three-dimensional figure that has been laid out like a pancake, right? And it could be folded to show you a three-dimensional solid. Okay, so one thing you're sometimes asked to do is to draw a net of a three-dimensional figure. So we're going to draw a net now. Let me make sure that this is... So we're going to draw a net for this figure. Everyone look at this figure. Does this have one or two bases? This has...
one.
Does it have two parallel sides that are congruent? Then this is got how many bases? Two bases, right? The two sides that are parallel and congruent, clones, are what shape?
Triangles.
They're triangles, right? So is this figure sitting on its base? Look at this figure. Is it sitting on its base? No, it's sitting on one of the sides, the lateral surfaces. Okay? So prisms are not always sitting on their bases. In this case, the bases are the triangles in the front of the figure and look like behind. So what if the bases are triangles, what type of a prism is this? It's named for the bases. Remember yesterday?
Prism.
A triangular prism. So everyone say it. A
Triangular prism.
because it's named for its bases. That's right. So you've got to look at the figure, and if anything else, at least imagine a pyramid. Does that thing look like this pyramid? No, pyramids have a sharp point. They always have a sharp point. Okay? And so this definitely is a prism. And then you say, well, what are the two parallel clones? Congruent sides. And they're triangles. So triangular prism. Okay? So in order to draw it, in case you want a little guidance, I'll draw it one more time. We start by drawing the two clone bases. So draw yourself a triangle face that's kind of facing you. And as I look at the back face, the back base, we can only see the top edge of it, the way it's oriented here. So I'm going to draw a clone of this triangle, but I only see that edge. The other two edges, I'm going to dash. Once you have your two bases, you know you've got your prism when you just attach consecutive vertices, right? So then that goes there. This goes here. Whoops, that was a little bit visible there, that section. And there. We actually see a little bit more in the red prism than we do in the black. But anyway. Okay, so that's the three-dimensional triangular prism. And now to draw the net, we need to draw a flat group of areas that could fold into this, right? Like as though you took a net and spread it over the whole thing and then you lay it out flat. Just like these templates that you've cut out. You actually have a triangular prism cut out, don't you? The one that you've cut out looks like the bases are equilateral. This looks more like a right triangle base in the picture here. So how many sides, lateral surfaces are there? We already said there are two bases, but how many lateral rectangular sides are there? Do you see it, Riley? How many lateral surfaces, which mean not the bases? The bases are the two triangles. So how many? Are there only two lateral rectangles to this? Does anyone see two lateral surfaces? Does anyone see something different? So if we draw three surfaces, what shape is, in this case, the bottom side? The way this thing is sitting. What shape is that bottom side? Wesley? Rectangle. So we're going to draw that shape. What shape is this top side if we flop it out to the left? What shape is it? Yeah. This top side is a triangle?
No, rectangle.
It's a square or rectangle. We don't have the dimensions, but let's just say it's like a rectangle. We're just laying this thing out. What about this back side, back here? If we lay it out to the right, what shape is it?
Square.
A square or rectangle again, we don't know the dimensions, okay? And then the two sides that we're missing in our net are called the whats? They're the bases, right? So look at here, where this one comes off, we have kind of the top part of the triangle, and it goes down to the base. And we have the second base connected there. Good.
Looks like a spaceship.
It does. It looks like an airplane or something. So we could have drawn it differently, but this is one way that you could create a net for this triangular prism. Okay? So the surface area then of this figure would be what? Can somebody define that for us? Surface area is the sum of all the areas of all the faces, all the surfaces. Have you noticed that faces is part of the word surface? Have you ever noticed that? Is that why we have faces? Because it's our surface? I do not want you to write this part. I just want you to watch. If we were in 5th grade, or sometimes even in 6th grade, you might look at a rectangular prism at those grade levels, and I'm sure you did this in 5th grade, and you would say, how do we find the surfaces of all this rectangular prism? And they might even give you the picture of the net like you see here. Here it is, all laid out flat. So how would a 5th grader do this? Come on. Hey, they would add them all up. So look at, if I could make a little plan. And they often don't make good plans in 5th grade, but as a teacher I might say, well, let's try to make a plan so we make sure we get every surface, right? Every piece. So we can number them. 1, 2, 3, 4, 5, 6. We have 6 different little areas, so we got to go find all 6, right? So then you could say, oh, the total area will be the area of 1 plus the area of 2 plus the area of 3 plus the area of 4 plus the area of 5 plus the area of 6. Now, we're not going to do it this way in 7th grade. But could we do it this way?
Yes.
Yes, and we could get the right answer. Okay, so let's just do it really quick to see what we get when we do this. When you do this, you have to say, what is the shape of area 1?
Rectangle.
3, 2, 1.
Rectangle.
So how do you find the area of a rectangle? A equals?
B.
So you have to go BH. Now, are all of these surfaces rectangles?
Yes.
Is a square a rectangle?
Yes.
Yes, so we could use BH for all of them. But when we go find BH, don't we have to be careful about what is our base and what is our height for each of these, right? So we start with the first one, number 1. So what is the base and height there? Everyone? The base of this number 1 area is, what's this? 12, and what's the height?
25.
Oh, you had to go over here and find it. Oh, good job, 5th grade. Okay, so we have 12 times 5, or 25. How about area 2? Do you see it?
12 and 5.
You can solve one, good, and then find a whole bunch of the others. That's right. So that's why we use a different formula, because we can see that there's repetitive multiplication. So there must be something repeating here. But let's just quick. Okay, so there's a very long way to find every little piece and add them up and you now have the surface area, okay? What we're here to do in 7th grade is use a plan, but use a plan that will get us there a little bit quicker because we see this repeated multiplication. And here's your plan. For a prism, we know we have to find 2 base areas, which is a capital B. First time we've used a capital B in our formula. Plus, we're going to take the perimeter of the base. I just put that word there so you know which perimeter to find. Take the perimeter of the base and multiply by the height, which is the distance between the 2 bases. This is actually the distance between the 2 bases. Height is not always up and down. We can lay on our sides, we can lay down on our bellies, and our height is still from the top of our head to the bottom of our feet. So height is distance between the 2 bases. It's really, really important that you understand what a prism is. A prism has how many bases? 2. That's so critical. If you don't have that, then it would be tough to come up with the formula, right? It has 2 bases, plus all you have to do is walk around the base and times it by the height, and you have the lateral surface, the other sides, okay? So we're going to use this on 2 examples here, and we're going to start by drawing them. So go ahead and draw. So you look at the figure and you see it is not a pointy Egyptian pyramid. So this must be a prism. So you say the area equals the 2 base areas plus I got to walk around my base area times the height of the prism. Okay? And so the next step is to decide what your base is. What shape is the base? Now, this particular figure is that exceptional figure that any side could be a base because they all have an opposite clown parallel to them. So, can somebody select a base for us? What base would you choose? Chris?
5.
5 times what? We need a side. We need a whole side, right? 5 times what?
3.
He's choosing 5 times 3. Do you see that? That is totally different than the last class. Somebody chose the bottom. We're going to go with Chris's. He's choosing this side to be the base. Okay, so I'm going to make a little note that he chose that as the base. What shape is the base, Chris? Rectangle. How do you find the area of a rectangle? So we go BH. Notice I have lowercase b now because this is the actual polygon, the rectangle. Okay? Plus, we're going to walk around that rectangle that he chose, that base, times the distance between the 2 clones that he has chosen. Okay? So now we substitute the numbers for his base he chose. So he just said we have 5 times 3. And we know this is going to be feet squared at the end. Now, he chose this base over here. So we need to now walk around it. So everyone walk around and get your number. The perimeter of the base is? 16. Good job, 16 feet. And then we're going to multiply it to the distance between the bases. And the distance is? Say it. 12 feet. Right. Because he chose this right side, we have to travel down between that side and its opposite clone over here to get the height. Good. Now, that work that you just did is worth 9 out of 10 points. You've done all the hard work that needs to be done to do this problem, okay? 1 point for getting the correct answer down here. So I'm going to pause, we'll come back and show you the answers. The reason we walk around the base is, if I take this piece of paper, I have folded it now into something that's like a rectangular prism. Do you see that? It's got 4 sides. The only thing it doesn't have are the bases. Imagine a square here and a square here, okay? So when I walk around the base, I could lay this out like a net, and I now have the whole bottom, right? And all of these rectangles have the same height. So I have found the gigantic rectangle that made up this prism. See that? So all prisms are just a gigantic rectangle that could be stretched out with different kinds of bases on their sides. Okay? And that's why we walk the perimeter of the base, which in this case was 16, and then multiply by 12. You get all 4 sides. Okay? If the bases are triangles, give me the area of a triangle now. A equals B, good, BH over 2. Plus we're going to walk around the triangle and the distance between the triangles. At home you're going to have to pause and come back. You'll need to pause and kind of look this over, make sure you have the right values, okay? And then here you go.